Hi there, this is Raymond. I am going to look at the problem implement queue using stacks. Implement a first in first out queue using only 2 stacks. The implemented queue should support all the functions of a normal queue: push, peek, pop, and empty. Implement the myQueue class. Okay, let's check out the first function and all the way down to the last function. So the first item that we need to look at to understand is push. We're pushing the item into a queue. That should be pretty simple. Let's just push the item into a queue. 2, pop. Well, we just need to pop an item from the queue. We just need to reverse the item. So let's say we have 1 and 2, and we have a second queue. That would we can pop everything while there's items in the push, and we just pop everything into our pop queue stack, and now we have 2 and 1, and this is our push stack. And now we can return all the items from the pop stack into the so this would be emptied and go into the pop stack, and we'll return everything. Okay, so peek, grab from pop stack if empty, attempt move items from push to pop, and grab from pop stack. Okay, and empty. Am I understanding here, or am I just planning out the code? Well, what happens if it's empty, right? What happens if we have an empty, what happens if they're both empty? Well, just return none. I think that's the right thing to do. And just return whether or not stack is empty or queue is empty. Both queue empty. Okay, I think that's all. So we must use a standard operation of stack only. That means we can only push to the top and peek from the top, check the size, and run is empty. Only those operations are valid. So we must create a stack that will allow us to do that. You may stimulate a stack using a list or a DQ as long as you use only a stack standard operation. So we don't actually need to create a class of the stack. We can just use our DQ or list to perform the operations of push, peek, and size, and empty. As long as we don't fall out of those parameters, we're good to go. So let's check out some of the constraints. Numbers that can be between 1 to 9, and at most 100 calls can be made. So whether it's 1 call or 20 calls, I don't think that makes a difference. The only thing that makes a difference is the empty. That's special. Okay, so that's going to be our edge case. And with a peek, it should just return none. Right. Empty should return true. What else do we have? Well, of course, pop should pop an item in. That's not an edge case. That's not something that we should be doing. No, pops item out. What should we pop? Pop nothing. And lastly, we have push. Of course, push will push an item in. I think that's the only difference here. There's no difference there. let's check out the happy case then. So let's move all of these into here. So let's say push an item into 1, just push an item in, pop, we should just pop out 1. If we have 1 item, then we should peek return 1. What else do we have? So if it's empty, if it's 1, then we should return false. That's all. So we have a happy case, we have the empty case, we're good to go. So match, we're going to be using the stack data structure. With that, we're ready to go, and we will do a plan. So the plan is we can create a stack as with the standard operations, push to top, peek from top, get the size, and check is empty. Okay, so that's what we do. Then we will make 2 stacks. We have a pop stack for popping and a push stack for pushing. We will then perform our push function, and we'll push all items into push stack. Second, pop. We will pop all items from pop stack. If empty, then refill from push stack. If empty, return none. Okay, we have peek. We will peek at pop stack. If empty, then refill from push stack. If empty, return none. Okay, lastly, we have the empty function. We will just return both push stack and pop stack empty. Okay, with that, we are ready to go. Let's get some space here. And follow up with our plan. It's class, my stack. And let's create a definition. Let's create an init function and a self. So in this function, let's create a self underscore stack. We will not be accessing this, and make an empty array. We need push self or self and x of int. We'll return none. What we'll grab here is self stack dot append x. Pretty simple, not bad. So pop self int return self stack dot pop. Perfect. Self define size. I'm not sure when we'll be using size, but yeah, we'll take it. Int return self stack, and we'll take the length of that. Perfect. Last, define empty self. Let's do an int bool and return length of stack. equals 0. Okay, great. With that, we are done with my stack, and let's get to our push and pop stacks. So again, hopefully we remember what we're doing here. When we're pushing items, we have a push stack, and when we're popping items, we have a pop stack. In essence, this is like a queue, because everything is done in O of n, because 1, 2, 3, and 3, 2, 1. And once this is empty, we can keep adding to this, right? And we can just keep popping and keep peaking until we need to do this again, and then we'll just pop everything in reverse while there's items in there, and we will refill it, and we'll keep going. It's just like a queue. Okay, so let's get back to it. Pop stack equals my stack. And self.pop stack, push stack, is equal to my stack. Okay, so let's push items in. So self.push stack dot push, and we're gonna push x. We're gonna push x in. Okay, so if pop stack, if self.pop stack, if there's an item in pop stack, then that means we're going to return self.popstack.pop. Otherwise, we will have to, while we have items in our push stack, while push stack, dot size is greater than 0. There we go. And while push stack is not empty, so empty and not, then we will move all the items self.push pop stack .push. We're going to push every single item from our push stack. And then we will return self.popstack.pop. Perfect. Now for our peaking. So the same thing. If it is not empty, then we will peak. Otherwise, we would move everything in, and then we'll peak again. So peak. Uh-oh. We don't have a peak function. We forgot to make a peak function. Okay, so here we go. We're just returning self.stack, the first item on the stack, the top item. Yeah. Okay, so peak, and we would peak again. The problem here is if self.popstack.empty return none, otherwise return peak. I think we should do the same here for the pop as well, just in case. Okay, with that, we are ready to check if it's empty. So return, we need to make sure that both are empty. So self.popstack.empty and self.pushstack.empty. And with that, I believe that we have completed the problem. And we can run through both examples. We'll run through one empty example and one this particular example. Okay, we're down to 15 minutes. I think we're pretty far along. Let's review just the empty one. So let's look at empty. When we push an item in. Good. When we pop, what happens? Oh, when we're pushing the second item in. And we do a peek. What happens when we peek? There are no items in our pop stack, so push stack. And our pop stack is currently empty. So what happens is that it's not empty. So while push stack is not empty, then we push everything into our pop stack. With our pop stack, if it's empty, return none. But it's not empty, so we'll take a look at the first item. So we return 1, perfect. And now we do a pop, and we look at our pop. There are items in the pop, so we'll just pop the first item, and then we'll get the 1. And now we're checking. Oh, of course, the push is now empty. My bad. And we're checking if it's empty. So is pop stack empty? No, it's not. So we'll return false for empty. So we're good. Let's try an empty, like just no items at all. And we'll try all the functions as well. So what do we expect from push? Push works properly. Pop will just return none. And peek will return none. And this should return false because both are empty, because push and pop are empty. Okay, so with that, I think we have done our review. And let's run the code, just to make sure. So indentation level is no good, apparently. Run. Pop stack. So my bad. We have not called the function properly. That is my bad. Empty is also not called properly. We need to fix that. That is important. Run code. We have a none issue here. So I believe that the pop stack is still empty and there is an error here. So the peak is also a problem. So the peak is not peaking properly either. So let's check that out, see what's going on with the print self.pop stack. We're not supposed to see this, but stack. Yeah, let's check it out. Let's see what's going on. Run the code. It's empty. Okay, let's check the push stack. Oh, okay. The push stack is still full. So for some reason, nothing's going into the push stack right now. And so self.push stack, self.pop, while not empty. So this is currently not empty. I'm not sure why it's not popping items from my push stack. Oh, because I didn't call it. Genius. Okay, I think we're ready. Let's run the code. All right, everything looks good. We have debugged the problem, and let's submit. We should be good to go. There is an issue, it seems. Oh, I know the issue because of this. There we go. Whoops. We solved that issue earlier. We did not call the empty function. This is the problem that we found. When you call a function empty, it feels kind of weird. Usually I would just put is empty to make it like a function to know that, oh, this is what it's doing, checking if it's empty or not. But this is the problem with naming the function sometimes. that causes issues. But we have solved the problem. Let's do some evaluation. And I think our evaluation is O of n for pop push. No, push is O of 1, sorry, because we just pushed the top. And O of n for pop, because we'll be having to push everything from our push stack into our pop stack and then push everything out. A lot of the times it's going to be O of 1 because everything's in our pop stack already and we just have to pop it off. But we still have to refill, but because we refill our pop stack in O of n time. Yeah, so it's O of n. Now we have the peaks that is also O of n. It's the same because we still also have to refill our pop stack. Like peak is gonna be O of 1. Like that's just how fast it is. But we do have to refill it sometimes, and wait, we don't have to refill it. No, we do have to refill it because sometimes we have nothing in our pop stack and we do have to refill it completely. So that's the logic there. And lastly, we have empty, and empty is just O of 1 because we're just running a function to check the length. So perfect. That's our evaluation. These are all time evaluations. And the space evaluation is going to be all the same. It's just number of items that we have, which is O of n. Yeah. And with that, we have completed the problem. If you enjoyed this video, like and subscribe. If you want more videos, check the link in the description below. And I hope you learned something today. So I'll see you in the next one. Thank you. Bye.